2024 Times 1 2 paper 2. This is HL question 10, the first question of section B. So it looks to be a continuous random variable PDF kind of question. Find the mode. The mode is the x value of the maximum point of the PDF. So that would means we'll graph it. So the maximum is when x is 1.5, so the mode is 1.5. Then they want the probability that x is between 1 to 2. That means you integrate from 1 to 2. The calculator probably can do it for you in the graph. So 1 to 2, you get 0.435. Then find the median. Median means if you integrate from the lowest bound to what value of x, of the PDF, would it give you a probability of 0.5? Alright, so the median is that value of m that would give you an integral of 0.5. For most calculator, it is actually possible to graph an integral like that. So you put 0.5. The m you put x as well. Turn out the calculator can understand that, even though the inside is also x. So this should be possible, I think, for all GDC. Yeah. Then you can actually find the intersection. It is when the x value is actually the m value. It's 1.69. So make sure you figure out how your GDC can do something like this. Now for this question, you might think, well, this is something that I can easily integrate, so I can actually integrate and then sub in m minus sub in 0.5, and then just graph that instead. Now for this question, that's possible, but in the past paper, there used to be sometimes the thing is actually not something you can integrate by hand. So you really need to rely on the calculator to do it. So make sure you figure out how your GDC can let you graph an integral where the unknown is the limit. I'm pretty sure even some old TI model can do that. Now the shop sell chocolate to customer at 25 per kilogram. However, the weight of chocolate bought is at least 0.75. The chocolate would be at a discount. Find the probability that a random customer spend at most $48. Okay, so pretty much we want to find the probability that someone would spend less than or equal to $48. And the random variable x on top is actually the weight of chocolate people would buy. So they would at least buy 0.5 kilogram and at most buy 3 kilogram. Okay, then you think, how can they spend $48? Well, if they buy more than 0.75, it will be $24 per kilogram. So as long as they buy less than 2 kilogram, then they will spend less than 48. And I don't think we need to care about that 0.75 yet in this part, because if x is so small that x is less than 0.75, then it will be $25 per kilogram, but he will buy less than 0.75 kilograms, so he would definitely spend less than 48 anyway. So this should be the answer. Where I need the original graph now. I don't need this integral thing. Well, actually I can still use this. I just need x to be 2, because that would be, because my x is really like the integration from 0.5 to x. So if I put x to be 2, that's already this, right? Because recall that for this PDF, x is between 0.5 to 3, so less than 2 automatically means x is between 0.5 to 2, which by definition it means you integrate the PDF from 0.5 to 2, which is exactly what I'm graphing. So I put in x to be 2, that's the probability. Okay. I mean, if that's too complicated for you, just graph it again and then integrate again. All right. And the expected amount spent per customer. I believe this is the complicated part. But if you know what to do, it's not too bad. Something similar, like some similar idea have occurred in SL in some sense, but obviously not with a PDF. The idea is this: if you buy less than 0.75, so if x is between 0.5 to 0.75, like that, then the chocolate would be $25 per kilogram. So you paid, so amount that you need to spend would be 25x. While if x is between 0.75 to 3, then your chocolate is $24 per kilogram. So your amount spent would be 24x. So we need to find the expectation of this. This might be slightly out of the syllabus, but the expectation of something that depends on the random variable x would be to integrate the gx, which is how your thing depends on x, times fx, which is the PDF, and then integrate from the lowest possible to the highest possible. But you kind of are expected to know this. For example, you would know that the expectation of x squared is really x squared times fx, and then integrate from the lowest possible value to the highest possible value. So yeah. And the gx this time is the amount. So it's like this. Right, so our gx would be 25x times fx. From 0.5 to 0.75, but from 0.75 to 3, our gx is 24x. Then we just type this to the calculator, get 1.5148 plus, if is from 7.5 to 3, you pay 24. So it's 39.4428. So you add them up. 40.95. How many 650 do you want? To the nearest cent. So 40.96. This is a cent. Alright. Okay. Okay, this part is quite hard. I get that compensate for the super easy section A.